Welcome back to Autistic. In this video, we're diving into memoization, a powerful technique to optimize your recursive functions. If you've ever faced slow performance with recursion, memoization is your solution. Let's learn how it works and explore some real-world examples. Memoization is a technique that stores the result of expensive function calls and reuses them when the same inputs occur again. It's like taking notes, so you don't have to solve the same problem twice. To implement memoization effectively, you need a data structure, such as an object or array, to save results, a key, which is a unique identifier for each input, and logic to check if a result exists before recalculating and to save new results as needed. Let's optimize the Fibonacci sequence using memoization. Without memoization, each recursive call repeats work, leading to exponential time complexity. With memoization, we store results and reuse them. Let's solve a classic recursion problem. How many ways can you travel on an m by n grid, starting at the top left corner and moving only right or down? To solve the grid traveler problem, we combine recursion with memoization to handle overlapping subproblems efficiently. Here's how it works. We use a memo array to store results for specific grid sizes. This allows us to reuse previously computed values instead of recalculating them. Each grid size is identified by a unique key, which is a combination of m and n. This ensures we can look up results accurately. For the base cases, if either dimension of the grid is 0, there are no ways to travel. If both dimensions are 1, there is exactly one way to travel. For the recursive case, we compute the total number of ways by traveling down one row and across one column, adding those results together. The computed value is then stored in the memo for future use, significantly improving performance for larger grids. While memoization is powerful, there are a few things to be mindful of. Storage limitations. Memoization requires memory to store results, which can become an issue for large problems. Key consistency. Ensure your keys are unique and consistent to avoid incorrect results. Use cases. Don't use memoization for problems without overlapping subproblems. Thanks for watching. Memoization is a game changer for optimizing recursion, and mastering it will elevate your coding skills. If you found this video helpful, please like, comment, and subscribe to my YouTube channel. Monetary donations via PayPal at autisticcoder@gmail.com, Cash App Autisticcoder, or Venmo Autisticcoder are also appreciated. Your support makes a huge difference.